So in this video, I'm going to be explaining how to use logarithmic properties. Okay? Don't be discouraged by this long list of properties. It looks very confusing, but it's not as confusing as you think. And I'll explain what this means right here. Okay? So this is something that you must know. Okay? And it's good to have in our, like I said, in our toolbox of things, of ways to be able to work with these problems. Okay, so again, we're going to take a look at logarithmic properties. Now this top one, okay, this one is the one that we did in the previous video, where I'm converting from exponential form to logarithmic or vice versa. This one, most of y'all already know, but I'm just gonna write, I wrote it just in case. But the natural log, okay, has a base e. So I wrote the natural log of x is equal to the log base e of x, okay? So most of us know this, but just in case if you didn't, make sure you know that the natural log has a base of e. In this one, I have two logarithmic functions of the same base, right? Both of these have a base of 10. There's nothing written there for my base, so we know that it's a 10, it's a common log, okay? So I have two logs of the same base being added. So I can write it as one quantity, a single quantity, just one log, by multiplying m and n. When I subtract, I'm going to divide, okay? And this one right here is called the power rule, right? I have a log base, base b, m raised to a power of n, okay? And that is equal to n times the log base b of m. So notice what I did there was I grabbed the n, and it's no longer an exponent, but instead we brought it to the front to be multiplied by log base b of m. So no longer an exponent, it's now a number being multiplied to this logarithmic function. Now I wrote these two in a different color because they're good to know and they'll save you a lot of time, but I mainly want you to learn these written in purple, okay? If you learn these, well, great, they make your life easier, okay? And let me just explain this one. Now this one looks very similar to this one, right? But the difference is the number I'm taking the log of is the same as my base. These two are not the same, but these two are. And when my base is the same number as this number, then I know that's going to equal my exponent. And lastly, if I take the log, any log, it could be the natural log base 3, log base 15, log base 10, whatever it is. If I take the log of 1, it will always equal 0, okay? Let me just show you an example of this one, okay? Let's just say I have log base 3, and I'm taking log of 3, and it's raised to the power of 2, okay? If I take a look at that, my base and this number are the same, just like here, they're both b's. So I know this is going to equal 2. Whatever my exponent is, it's going to equal 2. As opposed to this one, log base 10, and we know that when it's a base 10, we don't have to write it. But you know what? I'm going to choose log base 5, just so it's clear, okay? Okay, notice my base and this number are not the same. They're not the same. Okay, so what I do there is my exponent is now going to be multiplied to the front, to the log. So this will equal 2 times the log of log base 5 of 3. So all I did was grab this and brought it to the front. Okay, so here I have 3 examples, and it looks like the instructions, excuse me, say different things, but they all mean the same thing. And I did that on purpose so that you're not confused of what to do. Okay, when you see these instructions. So the first one says rewrite in the form log of C. Okay, so it looks like I have 2 logs here that are being added, and they want me to write this with just 1 log. So they want me to rewrite these 2 logs and condense it into just 1 log. Okay, well, if I take a look at my properties here, I'm adding 2 logs of the same base. I'm adding 2 logs. So what I do with m and n, I multiply. So I'm going to multiply 2 and x. So 2x. Okay. So this equals that. And we're done because it just has to rewrite. Condense the expression to the logarithm of a single quantity. Same thing. What am I doing? I'm condensing it. And this is 1 single quantity. But this time I notice that I have a log of the same base, but I'm subtracting. So when I subtract, I'm going to divide. So I'm going to write log, okay, and I'm going to write x minus 5 divided by second one, so 12. And I am finished there, okay? This last one is a really good one because if you understand how to do this, the rest will be easy. Okay, it got several curveballs in there. Now, the first thing I notice is that I have a plus sign between 2 logs of the same base, and then I'm subtracting also 2 logs of the same base. And I'm trying to write this into a single quantity from having 3 different logs. So what I'm going to do is start with these 2. I'm adding, so I know when I add, I multiply. But be careful, because I don't see any number being multiplied here. So the log has to be alone. The log, I can't have anything being multiplied to the log. Okay, first get rid of that number that you're being multiplied to, or is being multiplied to the log, to make it look like that, or like this, or like that. See, there's no number being multiplied, no number being multiplied, same. But here I have this 2 being multiplied to log, so how can I change this? Well, let's take a look at our properties. If you take a look at this one, I have a number being multiplied to the log of base b of m. Looks like that. 2 times log of x, right? So what did they do there? This can be rewritten as an exponent. So the n, or the number that I'm being multiplied to the log, can be written as the exponent. So I'm going to rewrite that. And before I do this, I'm going to rewrite this. I'm going to say, well, this can be rewritten as log x squared. And all I'm doing there is following this one, going that way. Okay, and I'm gonna rewrite the rest. Log of 5 minus 3 log of y. Okay, so I'm gonna grab these first two. Okay. Oh, as well, look at this. This 3 is being multiplied here, just like this one. So let's take care of this one too. Okay. Instead of multiplying the 3, let's write it as an exponent here. Okay. No, sometimes I write parentheses, sometimes I don't, but even if you don't, some parentheses are there. Okay. So I'm gonna take a look at these first two, right? Now I have all these logs alone, nothing being multiplied to them. Okay, so I'm gonna grab this one, and when I add, I multiply. So I'm gonna write this into one form. So log, I'm gonna grab this times that. So I will have 5x squared. Okay, and I'm just gonna rewrite this one minus the log of y cubed. Now, taking a look at these two, I want to write into one form, but we're subtracting now. And when we subtract, we're going to divide. So, just reading from left to right, I grabbed this first one, that's my numerator, 5x squared. I'm going to divide that by the second one. So, y cubed. And it's down to just one single quantity, which is what we wanted. Okay, so there I was able to apply 3 different properties in this problem, which is nice. So we went from 3 logarithms to just a single quantity.